Welcome to STEM the Learning Zone. Now, let us have an introductory session on motion in a plane problem solving approach. Whenever we deal with the motion in a plane, please keep in mind you must be very clear about the parameters position vector, velocity vector, and acceleration vector. It is almost all something like the interactivity or an understanding or an interdependency between these position vector, velocity vector, and acceleration vector is the only concept behind this one. And before going that, let me consider a basic approach. In motion in a plane, please consider a particle something like this and which is moving along a curve C. And now our job is to understand or to study the movement of this object or this particle. So the motion of a particle in a plane, it is taking turns. So initially it is going along x-axis and it is taking turn here. So it is going both the x and y axis, and again it is coming to the x-axis, and after some time it may go to the y-axis only, or after some time it may go to the x-axis only. So it is a combination of the two axes, that is plane. So it is planar motion. So let me consider coordinate system as we discussed in our motion straight line. To deal with any kinematics problem, you must consider or you must construct a coordinate system x, y. And let me consider an arbitrary point of this motion, that is, let me consider this as a P. P represent a position, how long it is from the origin. And from origin, it is at a distance, let us say r. And it is certain direction, let us say theta. So this object is, from coordinate geometry, it is x distance from the perpendicular, x distance from the y-axis, and y perpendicular distance from the x-axis. That is simple coordinates. And now coming to the polar form, it is at a distance r from the origin and in theta direction from the x-axis. So this magnitude and this direction constitute a vector here, and this is representing the position of a particle. So I can call this one as the position vector or direction. So this is about the position vector. And let me give you an idea here. Suppose if I take a construct right angle triangle here. So this is right angle triangle and which is making an angle theta here, and this is r. So I can represent this one as the coordinate x distance and this one as y distance. So by taking this right angle triangle straight away here, and this is theta, this is r, y, x, and from this right angle triangle we can write x equal to, or let me write simply cos theta is adjacent by hypotenuse x by r, and which you can give me x is equal to r cos theta. Similarly, sin theta equal to y by r, and that gives me y equal to r sin theta. And according to Pythagoras theorem, I can write this r equal to square root of x square plus y square. So these are the three important results from this one. And let me write it formally from this one: x equal to r cos theta, y equal to r sin theta, and tan theta equal to y by x, and r equal to square root of x square plus y square. And this is a basic setup regarding the position of an object. Sometimes we may need to understand about the speed or velocity. For that again, and keep in mind the tangent of the path at any time give you velocity vector. So let me choose that one here. Let me consider velocity v. And again it is an arbitrary direction. It is not along the y-axis, it is not along the x-axis. So the best practice for this one to study is resolve that vector. So let me resolve this velocity along the x-axis, which is making an angle phi with x-axis. So let me call it as a vx and let me call it as a vy. Again I can write here vx equal to v cos phi, and let me write this one as v sin phi. And we can write again the direction as tan phi equal to vy by vx. And again I can write the magnitude V is equal to square root of Vx square plus Vy square. And observe here, the entire thing is revolving around the concept of the vector resolution. Simple idea. So these are the formalities like Vx is V cos phi, Vy is V sin phi, tan phi is V by Vx, and V is square root of Vx square plus Vx square. And keep in mind the same thing can be, the same treatment can be done for acceleration also. Acceleration in the sense like A can be written as A in x direction, Ax in I direction plus Ay in j direction, whereas I can write Ax is equal to A cos theta and Ay equal to A sin theta, and I can write tan theta equal to Ay by Ax, and the magnitude A can be written as square root of Ax square plus Ay square. These are the similar kind of the analysis from the basic vector algebra, that is resolution of the vector. And now a simple idea behind the problem solving strategy is, as acceleration magnitude is constant in this case, so we are legally eligible to apply equations of motion. So I can write here V equal to U plus At, S equal to Ut plus half At square, and V square minus U square equal to 2 A dot R, that is dot product, and finally R equal to U plus V by 2 into T. This is average velocity actually. So these are the vector form of equations of motion in vector form. In vector form. And now we are at the edge of problem solving strategy. So we have completed the basic setup, like we have considered a particle and we have represented with position vector, and we are able to analyze the velocity at any time at any position, and we know about a similar treatment for the acceleration, and we know that entire thing is connected by time variable only. So this is about the basic initial setup idea for the mechanicals. Now to analyze this, the easiest method is, let us convert this motion in a two-dimension problem into the motion in one dimension. How can we achieve that? Very simple idea. Here, as velocity is resolved in two components Vx and Vy separately, so along Vx I have the position x, I have the velocity Vx, similarly I have the Ax along the x-axis. So position, velocity, acceleration, three are along x-axis, so I can study and I can apply whatever I learned in motion in straight line. And similar treatment can be applicable in the y direction. I know y, I know Vy, I know Ay. And time is the common variable which connects both x-axis and y-axis variables. So this is the idea for the problem solving in motion in plane. So for that, what we do, any general idea, we resolve the components into the x-axis and y-axis, and we solve the problems by applying the same equations of motion. Here, in along x component, like along x-axis, we have Vx equal to Ux plus Axt, x equal to Uxt plus half Axt square, Vx square minus Ux square equal to 2Ax times position x, and position, that means average displacement along x-axis is average velocity into time. And similarly we have along the y-axis Vy equal to Uy plus Ayt, and y equal to Uyt plus half Ayt square, and Vy square minus Uy square equal to 2Ayy, and the displacement along y direction, that is y equal to average velocity into time. So this is the only idea, this is the only thing which we follow for the problem solving in motion in a plane. So my dear students, seriously, the concept in motion in a plane is this one only. Remaining are just applications. Whether you take horizontal projectile or oblique projectile or projectile on inclined plane or relative motion, river boat or rainman umbrella, airplane and wind, all are based on this concept. Okay, I hope you understand, and let us start our strategy, problem solving strategy, and simply you keep in mind what kind of the problems are possible in this area, motion in a plane, other than projectiles and relative motion. A basic core concept, motion in a plane, which kind of the problems are expected in your JEE or NEET. Keep in mind the first kind of the problem is you will be given R1 position vector and R2. Okay, and you are expected to find out the displacement and velocity, displacement and distance. Displacement is simply change in position vector, that is R2 minus R1. Simple idea. And distance can be found out by distance. We know that. What is the distance actually? Distance is simply magnitude of displacement or magnitude of delta R, or I can write this as R2 minus R1 magnitude. Simple. So displacement and distance. And you may be asked to find out in another way, like second problem may be given like this. You may be asked to find out, see, R may be given as function of time. R may be given as function of time. And you need to find out from this. You need to find out from this what is displacement from T1 to T2. Simple idea. What is displacement formula actually? R2 minus R1. So in this case, R of T2 is R2, R of T2 is R2, and R of T1 is your R1. And after getting R1 and R2, you go to this. After getting R1, R2, you can solve by using the first model. And next kind of the question is velocity v at any time t. We know that whenever you have position in function of time, and velocity is simply the first derivative of position vector in terms of t with respect to time t. Now you may be asked to find out what is acceleration. So acceleration is again first derivative of the velocity of time. Okay, this is the basic idea, right? And sometimes you may be asked to find out by giving the data in another way. The third kind of the data may be given. Data may be given something like this. V is V at an angle theta, and R may be given R at an angle theta. Yes, and A may be given A at an angle theta. This is the one kind of the at an angle theta. Let us say this is theta 1, theta 2 and theta 3. And fourth kind of the data is V may be given in Vx in I direction, Vy in j direction, and R may be given as x in I direction plus y in j direction, and A may be given as ax in I direction plus ay in j direction. And remaining thing is simply application of our equations of motion. That's it. So, my dear students, I hope you are ready to solve the problems. Okay, now let us explore the same. Once observe this question. Calculate the displacement when particle is 5 meters due north and 12 meters due west. 5 meters due north and 12 meters due west. And sub question B, from point 1 to 2 having position vectors R1, R2. Now let us observe the first question, sub question A. It is given a particle is 5 meters, travelled 5 meters due north. So let me consider a particle and it is travelled due north, R1. And let me consider the second statement, 12 meters due west. So here, whenever you have the actual travelling, resultant we need to find out here. This is the individual displacement first journey, this is second journey individual displacement. So the resultant can be give you the displacement here. So R1 plus R2. R1 is 5j, R2 is 12 in minus I direction. So here displacement is equal to, here displacement equal to R1 plus R2, that is 5j cap minus 12 I cap meters. Now distance is nothing but magnitude, that is square root of 25 plus 144, that is 13 meters. Okay. Now coming to the sub question B. Sub question B is actually, if you observe, there are two position vectors R1, and from here an object travelled and reached the new position R2 here. This is R2, and we need to find out the shortest path. If you observe this one, actually, see here, it started here, it traveled R1, okay, and it traveled a shortest path, that is displacement, so that it reached final one, that is R2. If you observe here, according to triangle law of vector addition, identify which is co-initial point this one and co-terminal point this one. So this R2 equal to this R1 plus S, R1 plus the shortest path S. I want this S actually, so I can write this one S equal to R2 minus R1. If you forget the formula which we discussed earlier, you can follow this one, R2 minus R1. And simple idea here, once observe the data, R1 is 2i minus 3j plus 4k, this is R1, and R2 is 6i minus 6j plus 16k, just R2 minus R1 is our displacement. Now by doing this one, 6i minus 6j plus 16k minus 2i minus 3j plus 4k, and do here 6i minus 2i, 4i, minus 6j, minus into minus plus 3j, minus 3j, plus 16k minus 4k plus 12k. So I will get here displacement 4i minus 3j plus 12k. This is displacement completed. And now we need to find out the magnitude also. So whenever we have a vector in rectangular form, magnitude can be found out by using simple idea, square root of I coefficient square plus j coefficient square plus k coefficient square. And here I coefficient square 4, 4 square 16, j coefficient is minus 3 whole square 9, and k coefficient 12, 12 square 144. Here 16, 9, 144 is 169, square root of 169 is nothing but 13 meters. So this is idea, and this is very important and basic approach for the motion in a plane problems. Now let us focus on another kind. Suppose if your problem is given something like this, the position of your particle is given in terms of r as a function of time, and you need to find out what is the magnitude of velocity acceleration when time is 2 seconds. Okay, and we know already velocity from position vector is simply first derivative. So velocity can be written as dr by dt, and d by dt of what is r given here, 3t cube minus 2t I direction, 4 root t plus t j direction, 3t square minus 2 k direction. And we know that derivative of 3t cube, t cube derivative 3t square, right? So whenever we have this kind of the thing, 3t square, 3 into 3 9, 9t square, and 2t derivative 2, and here 4 root t, 4 root t, 4 root t means t 1 by 2, so I will get 1 by 2 times t power n minus 1, 1 by 2 minus 1, simply 1 by 2 root t, 2 cancel, 2 by root t, plus derivative of t 1 j cap plus 3 t square derivative 2t minus 2 derivative 0, so 3 into 2 actually 6t in k direction. So this is the idea behind this one. Now observe the differentiation of this one, actually v equal to this one 90 square minus 2i minus 2 by root t plus 1 j plus 60k. And the questions are not only velocity, we have acceleration also. Now acceleration is the first derivative of the velocity, so I can write a equal to dv by dt. Again derivative of 90 square 18t, 90 square derivative is how much? This is 18t, and derivative of 2 0, 2 by root 2 t power minus 3 by 2, and derivative of 1 0, derivative of 60 6, and that is your acceleration 18t in I direction plus t power minus 3 by 2 j direction plus 6k. Now we are done. Finally, to get the velocity at time t equal to 2, just to substitute here this t equal to 2 seconds. And acceleration when t equal to 2, just to substitute here this t equal to 2 in this one. Simple. And now let me do this the same thing, like v is given, we got it from the first derivative of the position vector. Now when t equal to 2 seconds, v equal to, substitute 2 here, 9 into 2 square root 36 minus 2 34, 2 by square root of 2, so root 2 plus 1, and 66 into 2 12. So that is the only idea available here. And after solving this one and magnitude we want actually, so square root of 34 square plus 2.414 square plus 12 square, we will be getting approximately the value is 36.1 meter per second. Now similarly for acceleration we should do. For acceleration, if you observe, acceleration time function is there, and simply by substituting t equal to 2 seconds, 18 into 2, 36, and t power minus 3 by 2, actually that is 1 by t root 2, that is if you substitute 2, that is 1 by 2 root 2 whole square. So you will be getting simply 1 by 8 plus 6 square, 36. 1 by 8 is nothing but 0.125. Now, so 18 square plus 2 pi minus 3 by 2 whole square plus 6 square, we are going to get finally, after getting the magnitude, A equal to approximately 36.5 meter per second square. This is basic approach of the problem solving in motion in a plane. And finally, another kind of the thing here you observe, the velocity of a particle is given and you need to find out what is the displacement of the particle during the time interval t is equal to 1, 2, 3. Usually if the position as a function of time is given, velocity we will do with the differentiation. Suppose if you are given velocity as a function of time, displacement can be obtained by reverse process, integration, definite integral. You have the limits t equal to 1 second to t equal to 3 seconds. That's it. And find out r of t here. That is by integration. Okay. And r of t, dr equal to v dt, by integrating on both sides, you are going to get velocity is given 3I plus 6 minus 2t j. Integral of 3, 3t. And integral of 6, 6t. Integral of 2t, 2t square by 2, that is simply t square. So this is the final position. And we want a displacement from 1 to 3. We want displacement from 1 to 3. Now just to substitute. When t equal to 1 second and 3 seconds. When t equal to 1 seconds, the position is 3i plus 5j. When t equal to 3 seconds, the position is 9i plus 9j. We want displacement. So final minus initial, r2 minus r1. So by subtracting this one, 3i plus 5j minus 9i plus 9j, 9i plus 3i 6i, 9j minus 5j, 4j. So simply I will be getting 6i plus 4j meters. This is displacement. Now let us discuss about another kind of the question which is given in different way. A particle is moving in the xy plane with constant acceleration. The value is 1.5 meter per second square, which is making an angle 37 degrees with x-axis. So here acceleration given in polar form, magnitude at an angle theta. Now at t equal to 0, initially the particle is at the origin, so initial position also given, x is 0, y is 0, and its velocity initially, that is u along x-axis, 8 meter per second. Here initially there is no velocity along y-axis, so uy is 0. Now find the velocity and position when time is 4 seconds. Given that sin 37 is 0.6, we require that value. So when sin 37 is 0.6 and cos 37 must be 0.8. Okay. Now let us go through. It is given that with x-axis the acceleration is making an angle 37 degrees here. Initially the velocity is along x-axis, which is 8 meter per second. Acceleration is by making an angle. We can resolve this acceleration along x-axis, along y-axis. So ax is 0.8 into 1.5 and ay is 0.6 into 1.5. So now observe this one. It is going to be very easier question for you because it is just a matter of equations of motion. So now we must resolve that into the two components, x-axis and y-axis, right? So by resolving this a as ax and ay, you just keep in mind that figure. Now ax is a cos 37. Just by simplifying this one, we are going to get ax value as 1.2 meter per second square. And similarly ay, a sin 37, you are going to get 0.9 meter per second square. Simple idea. Now coming to the initial conditions in the problem, at t equal to 0, initial velocity along y-axis 0 and initial position also 0 along y-axis. And along x-axis, initial velocity 8 meter per second and initial position is 0. Just by keeping these things, which one? Ux, x and AX. Uy, y and ay. Here if you observe, this is constant and this is also constant. Whenever you have acceleration constant, keep in mind we are legally eligible, we are legally allowed to use equations of motion. So along x-axis, along y-axis, we go through that one only. And we know that v is ux plus axt. So ux is 8 plus ax is 1.2, t is 4 seconds, because the question is asked at 4 seconds what is position. To find the position of the particle, I mean velocity and position. So first velocity and next position. For velocity v is equal to u plus 8, and for position simply uxt plus of axt square, second equation of motion. Now see here, just by substituting we are going to get Vx is equal to 12.8 meter per second. And coming to this one, at t equal 0 along the y direction, we can apply Vy is Uy plus Ayt. Uy value is 0, Ay is 0.9 and t is 4. So you are going to get 3.6. And now by solving for the final velocity, square root of Vx square plus Vy square, which we discussed at the beginning of this session. And by just simplifying this one, we are going to get 13.3 meter per second. Yes. Now, similarly, to angle of the velocity, tan theta is Vy by Vx. So by solving this one, we are going to get tan inverse of 9 by 32. So this is about the velocity. And similarly, we can go for the position also by applying second equation of motion. So we know that the x coordinate t equal to 4 seconds can be find out by uxt plus half axt square. Ux is 8, t value is 4. Ax is 1.2, t value is 4. Just by substituting, I am going to get x value as 1.6 meters. And on the y coordinate, same idea, simple. Uyt plus half ayt square. So this uy is 0, so simply it will become 0. And now half ayt square, half 0.916, that is 7.2 meters. Thus, the coordinates of the particle at 4 seconds will be 41.6 meters and 7.2 meters from the origin. Yes, this is the basic idea and basic approach in motion in a plane. When you are strong at this concept, your application level and problem solving approach in your projectile concept as well as in relative motion concept, they are going to be easier. And all the best for your JEE 2024. If you have any queries and if you need any videos on challenging concepts, please comment whichever the concept you want for videos. Okay? Please subscribe, share to as many students as possible. Thank you.